Hey, how are you doing guys? I'm Doha and for this video we are going to build a cat family classification system using Fast.ai, so let's get started. The goal of this project is to show you how to build a model by using your own dataset. So I'm gonna show you how to build a model that can classify between lion, tiger, cougar, caracal, cheetah and ocelot images. And here's the images for a cat family animals. And these are the steps we are going to follow to build our own system. So first of all, we are going to import the required libraries, download the data, verify the data, make data loaders, make learner, train the model, and the last thing is interpretation of our results. So let's get started. First of all, you need to make sure that you change your processor to GPU. So as I showed you in the last video how to change it. So go to runtime and then go to change runtime type, and then you can go with GPU from here. Okay, so now we are going to install our two required libraries. The first one is a fastai. So this code here is going to install it for us by using a pip install, and the second one is a Bing image downloader, which is a Python library that allows us to download images from a Microsoft Bing search engine. So we are going to use this library to download our own dataset. So, and here's the exact imports for everything we are going to use for today's task. So I don't want to confuse you about all of these for now. I will explain for you what exactly they are in the code below. So now we are ready to download our data by using a Bing image downloader. So as I told you, it's a Python library that allows users to download images from Bing search engine. It provides an easy to use interface for searching and downloading images based on keywords or phrases. The library uses the Bing search API to retrieve image results and then download them to the local machine. For our task for today, we are going to download our data into a directory that we are going to make. Then this library can be useful for developers who need to download large numbers of images for data analysis, machine learning, or other purposes. And here's the link for its website. Okay, so now here's the code to make a directory. So it's exclamation mark followed by mkdir, which stands for make directory, and then the name of our directory, which is a cat family directory. So after run this cell here, you can show your directory from a files. Okay, so now our directory is made for us. Let's grab our images. For this task, you need to import a downloader object from Bing image downloader. And here's a code that will import it for us. Then we are going to use a download method, which allows us to download images from Microsoft Bing search engine. So this takes three arguments. The first argument here is the query, which is the name of the image that you want to search for. So the more correct and specific your query, the better data you will get. So here we ask it to search for a cheetah animal images, and then we pass it the number of images that we wanted to download. So we pass it a 70, and then the last argument here we pass it the name of the directory that our data will stored in. So we passed a cat family directory, which we define in this cell above. So in summary, this cell here is going to ask a Bing image downloader to download for us 70 images of cheetah and store them into a cat family directory. So instead of cheetah or instead of 70, you can ask it for any number of images or any type of images you want. So after run this cell here, it will make a data animal folder in our cat family directory. So let's check it now. Okay, go to files and then go to a cat family. So here's our cheetah animal folder. Okay, and here's our images. So let's open this image, for example. Okay, and here's the image of a cheetah. Okay, so now, so here in this code here, we are going to download a tiger images. The same code as the code in the above cell. We ask it to download for us a 70 number of tiger images and store them into our cat family directory. And here we ask it to download for us a lion animal images, and here a cougar animal. As I told you, you can ask it for any type of image you want. So here is a caracal animal images, and here to download an ocelot animal images. Okay, so now our data is ready. Okay, so for now, after we have downloaded our images, we need to check the validity of our images. So verifying images involves checking for any errors or inconsistencies in the data, such as mislabeled images or corrupted files. So by verifying images before training a model, we can avoid potential issues that could lead to inaccurate predictions or poor performance. So in Fast.ai, the verify images function is used to verify the validity of images in a given directory. It checks for any corrupt or invalid images and removes them from the directory. This function is particularly useful when working with large datasets that can contain a significant number of invalid images. By using verify images, you can ensure that your dataset only contains valid images, which can improve the accuracy of our machine learning models. So, okay, for now we are going to make a list of our categories. So we have so basically these are the name of our folders in our cat family directory. So we have all of these folders on it. So first folder we have a cheetah animal folder, tiger animal folder, and so on. And then in this code here we are going to remake our existing directory but by using a path module in Python. So if you're wondering why we do this, because a path module provides a more intuitive syntax for working with file paths and directories and better for error handling. Okay, in this code here, I'm going to make a directory called a cat family. So in our case here, we already have an existing directory with this name. So we pass it this argument exist underscore okay equal true. So this argument ensures that no error is raised if the directory already exists. And this argument here, parents equal true, ensures that any necessary parents directory are also created if they don't already exist. Okay, and this code here, we are going to verify our images. So let's break it down for you. In the first line here, we are going to create an empty list using L function from a Fast.ai library. And the second line for n in the classes, it iterates over all classes list, which is we have defined here in this cell. Okay, and print n is going to print the name of the current class to the console, so you can see it here. Okay, and this code here is going to create a new path object by joining the base path with the current class name. Then the last line here is going to verify all images in the current class directory and add them to image list that we have defined in the first line here. Okay, so as I told you, a verify function is going to check that each image file is valid and can be opened without error. Okay, so .ls here, it's a function that return a list of all files in the directory. Okay, so in this cell here, we are going to print our images list. So as you can see the results here, there is no invalid image. So now we are ready to make our data loaders. So in Fast.ai, data loaders are a set of classes that help in loading and transforming data for machine learning models. They provide an easy-to-use interface for loading data from various sources such as CSV files, image folders, as we are going to use for today's task, and databases. Data loaders also allow for efficient loading of data in batches, which is essential for training deep learning models on large datasets. Additionally, they provide functionality for data augmentation and normalization, which can improve the performance of machine learning models. Okay, so in the cell here, we are going to define a data block for our task. So this block is consisting of two blocks. Image block, which is for loading and pre-processing the image data, and the second block is a category block, which is for labeling the images with corresponding categories. Okay, so get underscore items argument here is specify how to retrieve the images file from a given path, and the splitter argument define how to split the data into training and validation set. So here we are going to random split um, our data by 0.2. So it's randomly split our data into 80% is going to our training dataset and 20% is going for our validation dataset. And get why argument here is specify how to extract the category label from each image file name. So here we are going to use a parent label, which label an image with the name of the folder in that is stored in. Okay, so this argument here is going to applying a random resized crop to our input images with a target size of 460. And the last argument here is going to define a list of batch transforms to be applied to our input images. So as I told you in the last video, the augmentation process is going to generate a new data from our existing dataset. So this function here, augmentation transforms function, applies a set of random augmentations to our input images, including resizing them with a specified size. So now we define it to be 224, and then it's randomly wrapping them. Okay, and this function here is going to normalize the pixels value of the input images. And finally, with this code here, we create a data loader object, DLS, on the data block that we defined above in this cell. Okay, so we pass it a number of batch size is going to be 32, and pass it a path of our images. So if you forgot what is a batch size, so it's a number of samples that are processed into one forward or backward pass of our neural network during a training process. Okay, so now we are going to show a 15 image from our data loader. So these are a 15 images that we are grabbed them randomly. Okay, so for now that we have created our data loaders, we can build our vision learner to use it for training our model. The vision learner would be responsible for taking the data from data loader and using it to train a model. So in this task, we are going to use a ResNet 34. In Fast.ai, ResNet 34 is a convolutional neural network architecture that consists of 34 layers. It's a variant of a ResNet family of models that was introduced by Microsoft Research in 2015. ResNet 34 has been pre-trained on ImageNet dataset and can be fine-tuned for various computer vision tasks such as image classification, object detection, and segmentation. And here's the image of its architecture. Okay, so in this cell here, we are going to define our vision learner. So we pass it our DLS, which is our data loaders, and then we pass it our ResNet 34, which is our architecture, and then we tell it that we are going to use a pre-trained model, and then we defined our error rate matrix. So this function here is going to convert a model weights and activations to be 16 bit floating point precision. Okay, so for now we are going to train our model by using a fit1cycle function, and we pass it a number of epochs. So for today's task, we train our model by using a 4 epochs. So after training our model, these are our results, and this cell here we are going to save our model. So in this final section here, we are going to look at our results by using classification interpretation class from Fast.ai. We can easily view the results of our classification model. This class provides us with a variety of visualizations and matrices to help us understand how our model is performing. We can view the confusion matrix, which shows us how many samples were correctly classified and how were misclassified. We can also view the top losses, which shows us the samples that were most difficult for our model to classify. Okay, so first of all, we need to load our saved model. So this line of code here is going to load it for us, and then we are going to pass our loaded model to a classification interpretation class here, and then we pass it to interp variable here. So to show, okay, so here code we are going to show you a confusion matrix. So to show a confusion matrix, just use a plot underscore confusion underscore matrix method from Fast.ai. So as you can see here, here's our actual labels, and here's our predicted labels, and here's our results. Okay, so for the last cell here, we are going to show you our top losses. So this images here is images of categories that our model is missed to classify them. So the first part is going to be our prediction label, then our actual label, and then the loss, and the last thing is a probability. So for this image here, the predicted label is going to be a ocelot animal, and actual label was a cheetah animal with loss 4.81 and probability 0.95. And for this image here, the prediction label was a caracal animal, and the actual label is cheetah animal with loss 3.37 and probability 0.95, and so on for this image. Okay, so that's it for today's video. Hope you, after this video, you make your own system by your own dataset.